In today's video, we're going to look at section 5-4, complex numbers, and we're going to split this into multiple parts. And today, we're going to talk about part 1. So let's get started. The first thing we need to understand about is some properties of square roots. For non-negative real numbers a and b, the square root of a times b can be split into the square root of a times the square root of b. And as a fraction, the square root of a over b can be equal to the square root of a over the square root of b. So we can literally chop them in half. So for the examples, the square root of 3 times 2, we can split that into the square root of 3 times the square root of 2, and the square root of 1 over 4, we can split horizontally into the square root of 1 over the square root of 4. And that helps us simplify them because in square roots, we don't want any radicals underneath or in the denominator, and we don't want any perfect squares underneath the radical. We want to simplify it as much as possible. So let's look at some examples. So the square root of 50. So in 50, I want to look for any factors of 50 that have that are perfect squares. So my perfect squares I'm looking at are like 1, 4, 9. I skipped one. 16 would be the next one. 25, 36, and these are all, say, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. So that's what I'm looking for, and so on. So I know that the square root of 50 can be rewritten as 25 times 2 because 25 is a perfect square. So what I'm going to do is I'm going to split that in half and get the square root of, sorry about that, I'm jumping ahead. The square root of 25 times the square root of 2. So now I have, well, the square root of 25, as we see off to the right over here in this list, 25 is just 5 squared, so the square root of 25 would just be 5, and I can't do anything to the square root of 2, so I leave it as a square root of 2, and I'm done. So now let's look at the square root of 11 over 49. So in this one, I want to split that horizontally. So I get the square root of 11 over the square root of 49. Now the square root of 11, I can't do anything, so I'm going to leave it. But the square root of 49 is actually just 7. So there we have it. We're done. Okay, let's go to the next one. So it's the square root of 45. So the square root of 45, well, I know I can write 45 as 9 times 5. So once again, I'm going to split that in half, and I get the square root of 9 times the square root of 5. And the square root of 9 is just 3, and I cannot do anything to the square root of 5, so I leave it, and I'm done. Okay, the square root of 32 over 81, I'm going to split in half. So I get the square root of 32 over the square root of 81. Well, on the bottom, that one's pretty easy. The square root of 81, that's just 9. But the square root of 32, wait a minute, I know I can rewrite that as 16 times 2. So I have the square root of 16 times 2 over 9, and I'm going to keep going. I'm going to split it. And I get the square root of 16 times the square root of 2 all over 9. Square root of 16 is just 4, so I get 4 times the square root of 2 all over 9. Alright, so that's some basic introduction with radicals. So now we have to introduce the imaginary unit, I, because we cannot take the square root of a negative number. So when we see a square root of a negative number, we want to take that square root or the square root of the negative and pull the I out. So as soon as you see a negative under the square root, get rid of that negative and put an I out there. So I'll show you. So here we have the square root of negative 18. Well, I see that negative, so I'm going to take that negative and I'm going to get rid of it, and I'm going to rewrite it as I square root of 18. Now I'm going to work with 18. So now I have I times the square root of 9 times 2, split that. And now the square root of 9 is just 3. So I get 3i times the square root of 2. Okay, and we're not going to look at this one, so ignore that one. So that's what we are looking at. So now, let's keep going. Negative 2i times 7i. Well, this way just works in reverse. If we know the square root of negative 1 is equal to I, if we square both of them, that means negative 1 is equal to I squared. So I can be treated as a variable. So I get negative 14 because negative 2 times 7 is 14, and then I get I squared. And as I just showed, I squared is just negative 1. So that becomes negative 1, so I'm left with negative 14 times negative 1, which just gives me 14. Now in this case, part B, we want to take that negative out right away. So we get negative, take that negative out. That negative becomes I, so I squared of 10 times I squared of 15. And now I can combine some things. I times I is just I squared, and then square root of 10 times the square root of 15 is the square root of 150. So from there, I squared just becomes negative 1. I can rewrite 150 as 25 times 6. Now we're going to split that. Negative 1 times the square root of 25 times the square root of 6. And then we just end up with negative 5 times the square root of 6. And there's your answer.